Today we know that an atom has a central, positively charged nucleus, and most of the mass of the atom is concentrated in the nucleus alone. At the same time, it is generally believed that the negatively charged electrons in the atom are in a state of continuous motion. However, in reality, there is no evidence for this kind of motion of electrons in atoms. In fact, when we go through the history of the development of today's atomic theory, we can see that the idea of the electron's motion around the nucleus is simply a mental construct of Rutherford and Bohr. Therefore, the most important questions about the structure of atoms still remains. What gives an atom its volume? Why the negatively charged electrons are not collapsing into the nucleus? In one of the last videos we saw that, contrary to the present-day belief, the space-filling substance ether is real and it can be experimentally verified. Here, if space is filled with ether, then the space inside an atom also must be filled with ether. Perhaps the attraction of the nucleus maintains a denser region of ether around the nucleus. We know that an atom of an element can absorb only some specific wavelength photons, and also the same atom emits the exact same wavelength photons when it is excited. Here my conclusion is that the electrons in an atom are situated in a kind of resonant columns. Since the space inside an atom is filled with ether, we can conclude that the resonant columns in an atom are formed by ether. At high pressure, a gas can emit nearly a continuous spectrum of radiations when the atoms in the gas are excited. This indicates that an atom consists of an enormous number of resonant columns in it. Inner electrons emit short wavelength photons and outer electrons emit long wavelength photons. This suggests that inner regions have higher frequency resonant frequencies and outer regions have lower frequency resonant frequencies. This also shows that the density of ether near the nucleus is higher and it decreases with increasing distance from the nucleus. This may be because of the greater attractions on near regions from the nucleus and lower attractions on far regions from the nucleus. Since the greater attractions on near regions, the ether density becomes more in the inner regions and vice versa. From these factors, we can conclude that the electron configuration in a multi-electron atom is determined by three factors: attraction from the nucleus, buoyant force exerted by ether, and repulsion between electrons. An atom has two types of shells: electron shells and transitory shells. Electron shells are the regions in which the electrons in an atom are situated and the atom is in a non-excited state. Transitory shells are the regions in which the electrons are ejected from an electron shell and an atom is excited. Hydrogen and helium atoms have one electron shell and an enormous number of transitory shells. Lithium atoms have two electron shells and an enormous number of transitory shells, and so on. The electrons in an atom can be excited in different ways: by incident photons, by the collision of particles like electrons, by the collisions between atoms, etc. Now let us see how an atom of an element creates its absorption spectrum and emission spectrum lines. If a photon incident on an atom's electron, and if the photon's frequency matches with the resonant frequency of the shell, electron's shell or transitory shell, in which the electron is currently occupied, then the electron will absorb that photon and vibrate with frequency of the incident photon. This causes the electron to emit a secondary photon with the same frequency of the incident photon at an oblique angle. Now, because the density of ether is greater in the inner regions, the electron will be expelled to an outer transitory shell. Now, if another photon with a frequency which matches with the resonant frequency of the above-stated transtory shell simultaneously incident on the electron will emit a third photon with the frequency of that incident photon and will be again ejected to a more outer transitory shell. At the same time, if the electron is incident by only one initial photon, then the electron will produce only one secondary photon and fall back to the original electron shell. This process of photon absorptions and emissions can explain the absorption spectrum and emission spectrum lines produced by an atom of an element. For a more detailed description for how an atom creates its absorption and emission lines, follow the link in the description.